Well, hey everybody, how's it going? This is Mr. Dawson here, and I am going to teach you about systems of equations substitution methods. So, this is just one other way we can find the answer when you're given two equations, and you need to find the one solution that works for both of them. So, let's take a look at what we got here. Alright, so let's start off with something a little bit more basic. Here's a pretty typical expression here, 3x minus 6 plus x squared. And this is an expression because there's no equal sign in it, blah, blah, blah. And the problem might ask you to evaluate the expression if x equals 2. So, if x equals 2, then we're going to substitute 2 in for these x's here. So it would be something like, let me get a pen, that'll probably help. 3 times 2 minus 6 plus 2 squared. And now all I did was I substituted that 2 in for each of the x's. So now order of operations says I have to do the exponents first, so that's 4. And over here we're going to get 6 from the multiplication. And there's my minus 6, so, and plus at this point between those two. So now I can start moving from left to right and doing my subtraction. 6 minus 6, well, that's 0, plus 4, and my answer will be 4. Nice, simple, clean answer. That's always fun. So that's how you substitute a number in. So if I want to substitute 2 in for x, that's what I would do. And it's similar to what we're going to do with systems of equations, but it's more complicated. So let's take a look at it. If you have looked at the other two styles of solution, either through graphing or through elimination, elimination in particular is all about getting rid of one of the variables. That's really important. And so we're going to use that to help us. We're going to use that same kind of idea and try to get rid of one of the variables. And in this case, you'll notice over here, it says y equals 6x minus 11. Well, that's in slope-intercept form. We could graph that. But this one's not. We'd have to solve this equation or solve for y in order to get into slope-intercept form. And then we could graph it. And sometimes it doesn't work out that even, and it's not very pretty. For example, here, we're going to have to divide by negative 3 in the end. Negative 7 divided by 3 is not an even number, so it's going to be hard to plot this accurately. So, what do you do? Well, this tells us what y equals. This equation up here says that y equals 6x minus 11. Well, if that's true, I can and it is true, let me tell you that. I can substitute in 6x minus 11 for my y right here. So, you're like, what? How's that going to work? Well, let me show you. I'm going to rewrite my negative 2x. That's not changing at all. And then it's negative 3 or minus 3 times whatever y is. And in this case, it's 6x minus 11 equals negative 7. Wow, my computer is going really slow today. So now we have only x's in here. That's a good thing because we can then solve for x and get one of those values and then substitute back in and get our value for y. But this is a messy equation, right? We have distribution, we have combining like terms, but that's what substitution does. So we're going to deal with that distribution first, this part over here. So I just dropped my negative 2x down. Now it's negative 3 times 6x, negative 18x, negative 3 times negative 11, that gives me a positive 33, and that's going to equal negative 7. Now I can combine like terms. I have these on the same side of the equal sign, so I don't have variables on both sides of the equation. I have them on both sides, on the same side, so I can just combine like terms. A negative 2x and a negative 18x is a negative 20x plus 33, and that equals negative 7. Okay, so now we're down to our two-step equation. If I subtract 33 from both sides, oh, you can see it forming. It's going to come out even. Isn't that nice? And negative 7 minus 33 is negative 40. Negative 40, look at that. That's a factor of 20. So we have x equals 2. Because positive 2, because negative divided by negative is a positive. So 40 divided by 20, we get 2. So that's our x value. So in my coordinate point, I know one of my answers for my x is going to be 2. So how do I find my y? I plug that 2 back into this original equation. I could put it into either one, but this is going to be simpler because it's already solved for y. Y equals 6x minus 11. So y is going to be equal to 6 times, instead of x, I'm going to put in my 2, 6 times 2, minus 11. So y equals 12 minus 11, and therefore y equals 1. So my solution coordinate point is 2, 1 for this problem. It's got a lot going on. It definitely does, and it's a big thing to substitute in, and it forces you to go back and remember how to do all those different things we've done over the course of the year in terms of distribution, combining like terms, solving equations with all those things in it. But it allows you to answer this question without having to rewrite either of these equations. And it's once you can get through this, it's actually a faster way than rewriting the equations. And so that's how you use substitution in order to solve a systems of equation problems. All right, hope you learned something, and let me know if you've got any questions. Take care. See you later.